What do we do when we have several queries that have common parts or share some common computations? How do we avoid using copy and paste to replicate these parts all over the application and also reduce the possibility of potential errors when we're copying these queries? What are SQL views and how can we use them to address some of these issues? If you want to find out, let's dive into this video and see the answers to these questions. Hello and welcome. My name is Elhelw. In a previous video, I talked about subqueries and common table expressions or CTEs. Both of them are ways to try to simplify our queries by separating some of the computations or some of the work into a separate query, whether that query is part of the main query as a subquery or if we define it in the beginning as a CTE or a common table expression. CTEs in particular can also help when we want to reuse that computation multiple times within the same query. So these are things that we talked about in that previous video, and I will link this video in the description as well as up on the screen here, so please take a look at it if you have not seen it already. Let's refresh what we talked about last time with an example. So let's start by listing some of the tables that we're looking at today. So we have our customers table with this information, customer ID, name, and address. We also have a stores table. Each store has an ID and also the city where that store is located. And then we have the orders table. Each order has order number, customer ID, amount of that order, the order date, and the store ID. So this is the data. And then suppose that we want to write a query that finds all the customers whose total amounts is greater than the average total amount across customers. Again, this is one of the queries that we used in the previous videos as well. So if you have seen it, then you're already familiar with this query. And in this particular case, we are using CTEs as a way to try to decompose this query into multiple steps. So the CTEs are defined with the with clause, as we have seen previously. So you have to say with, you define a name for your CTE, and then you put the definition, which is a subquery that represents that CTE. And you can have multiple CTEs within the same query before you reach the main select statement. So we have the first CTE, which we call the customer totals. This one groups by customer. For each customer, it sums up all the amounts of the orders for that customer. And the result of that, if we were to execute it separately, would look like this. So we have customer ID and total amount. And notice that because we're grouping by the customer, each customer has a single row in that output. The second CTE or common table expression computes the average across these total amounts. So just calls the average function, which will give us a single value. In this case, it's 170. And then what we actually want in the main query is to output all the customers whose total amount is greater than that average. So this is why we are referencing both CTEs in the main query, where the total amount is greater than the average that we just computed. And we will get a result that looks like this. This is an example of using CTEs to try to take out some of the computations of a query and make it simpler to read, as well as potentially reuse some of these computations. As you can see here, we have reused the customer totals CTE twice, once in the second CTE and once in the main query below. Otherwise, we would have had to repeat that query twice. So now the question is, what if we want to reuse computations across queries, not just within a single query? CTEs are only visible and effective within the same query where they're defined. So now, how do we do this across multiple queries? Without knowing anything else, the obvious answer would be we'll just have to copy the code or the subquery in all the queries where we want to use that. So as an example, let's look here. We have a query. We don't really need to get into the details of what this query is doing, but as you can see, there is a subquery there that we have. And consider that maybe our application has another query somewhere else that looks like this. It's a different query, it produces different results. But if you can look at both queries, you'll see that there is a common part that they're both using. So without knowing anything else, this is how people would do it. They would just take this part. If they know that they want to use that same computation somewhere else, they'll just copy it into the other query and write the other query on top of that. So this is one way to do it. This is also very common, especially in applications where you have some common computation. For example, like the computation that we're doing here, where we're multiplying the amount by 1.15, this is basically assuming that, let's say, we have a tax percentage which is like 15%. So we're trying to get the amount after tax, something like this. So you would see that same computations all over the place. Two issues with that. The first issue is that when you're writing the code, right, when you're writing that query as part of the application, so look at it from the application developer point of view, this query looks very complex. If the database administrator hands this query to the application developer and says, hey, like this is the part that you need to paste whenever you need to make that computation, sure, they'll paste it, but it can be complex. It can actually start causing them to make errors in the main query that they want to write, because every time they have to add this complex part to it. Especially if, like, it could be way more complex than this. Like, it could include multiple tables that could be like 2 pages long. So that makes every single query that they're writing also super complex. The other thing is that if you need to change anything in that subquery or in that computation, now it's all over the place and you have to find out where it is being referenced everywhere. Let's say we want to change this 1.15 to some other value. You have to find that everywhere. It could be repeated, 20 times, 30 times, 100 times. So you have to find all these locations, change all of them. It might also not be just changing this number. It could be changing the whole formula or the way you're computing a certain value. So you have to change this everywhere, which is a lot of work. But aside from the fact that it's a lot of work, it also has the potential of making mistakes. If you have to change this 100 times, you might make a mistake in one of these changes. You might forget to change one of the occurrences. And now all of a sudden you have your application is not consistent and it's producing incorrect results. So these are issues that we have to deal with whenever we have, repeated computations in multiple queries. So to handle these things, one possible way is using views. What is a view? A view is similar to a CTE. It's also a query that I define and I give it a name. The difference between a view and a CTE is that the CTE definition is within a query, in the beginning of a query. The view is defined separately from any queries. So you define the view separately. This view, its definition is actually stored in the database. And then you can use that in any query after that. You basically use it as if it were a virtual table. So whenever you're referencing that view, you can think of it as if it's a table that you're reading data from. Just like we did with CTEs, except in CTEs that was limited to within one query. A view is across multiple queries. So imagine that we have a bunch of tables in our database. We can use the \d in Postgres to list all the tables. So this will give us, the customers, orders, and stores tables that we have seen before. Now, suppose that we want to create a view to encompass that subquery, the one that we had with 1.15 computation that we've just seen. So to do that, we can use the create view command. So we say create view, we specify a name as, and then we list the query that we want. So this is the body or the definition of the view. Once we execute this command, we'll get the success message. So now we know that we have created this view and it exists in the database. How do we verify that it exists? If I do \d again, we're going to see this list. So we have the original 3 tables, and now we have an additional row that mentions the new name that we've just specified. And if you look at the type column, it says view, whereas the other 3 say table. So those 3 are tables, but this new one is a view. So now we know that it's actually stored in the database. Now I can use this view, anywhere I want. Also, if you want to look at what the view definition is, Postgres provides some catalog, structures and views and stuff like that where you can query. So we can say, select star from PG views. This is a system view that has all the views that were defined before. So if we select where the view name equals the one that we've just created, you will see that it has the view name, the owner, the schema, as well as the definition, which is the query that we used to define that view. So as I said, once we define a view like that, we can use it as if it were a virtual table. So we can select from it, we can do some joins with that view and other things. Basically, you can use it in any query the same way you use a table. So let's say select star from this view, it will give out the results of the view. One important thing to note, these results are not actually stored in the database. If I was selecting from a table, right, That table, the data is stored in the database, and the query would go and scan that table and produce the results. In the case of a view, this data is not actually stored in this form in the database. The view, the only thing that I store is the view definition, which is the query that we've seen here in the top, the query that we specified while creating the view. So when I do a query on that view, what happens is that the system will go, realize that this is a view, it will go fetch the definition, run that query, the definition of the view, produce the results, and then return these results as if it were reading from a virtual table. Well, okay, how do we verify that what I'm saying is true? One thing that we can always do is look at the query plan. If I look at the query plan for this particular query, if this was a regular table, like if I was saying select star from customers or from orders, one of the actual tables that we have, the plan would probably be very simple. It would be just like full scan over that table. But if we do explain for this query, it's not going to be a full scan over, this view. It's going to be this plan here that has scans from stores, scan from orders, and a join. So this is actually the plan to execute the view definition. The query that we have here at the top, which selects some data from both stores and orders and joins them together. This is the plan for that query. So doing a select from this view translates to fetching that whole query and running it, which this is why we get that plan for it. And you notice that in the plan, there is nothing called order totals with tax, because there is no table with that name. The data is coming actually from the original tables, the stores table and the orders table. All right, so now that we've defined this view, we can go back to one of our original queries that had this subquery, and we can replace that subquery with the view name. So now we can use it as if it were a table, and we will produce the same results as before. And again, if we try to explain this query here, we're not going to see a scan from a table. We're going to see the original view query, the view definition query, together with the other operations from this particular query, like the filter on the date and the grouping by the store ID. So we will see a plan that looks like this. So it joins the stores table with the orders table, and with all the filters and the aggregation that we have. So every time we reference a view, the system basically replaces that reference with the whole view definition into the main query, and then optimizes it and executes that. The fact that the data is not stored, like the view results are not stored, has two implications. One implication is that every time you change the data in the original tables, like the stores table or the orders table and so on, you don't need to do anything to like refresh or update the view results, right? Because the view results are not stored. So every time you are trying to read from the view, it's going to run that query over the original tables. And if the tables have been changed or updated, then this query will return the latest state of the tables. So basically, you don't need to do anything to keep this view up to date, because it's automatically updated because it reads from the original sources. So you have one source of truth, which is the original tables. The second implication is regarding performance. Again, because the data is not stored, like the results of the view are not stored, it doesn't really do anything in terms of performance. It does not make the performance of a query better or worse, because all it does is it executes that view definition again. So it's as if you had that whole subquery written in the main query like we had in the beginning. So if you compare the performance of the query that references the view versus the query that had the full subquery in it, it's going to be exactly the same, because they're both going to run the full thing and fetch the data from the base tables. So again, in terms of performance, no difference. One of the main advantages of using a view is simplifying queries, right? Like if you have a complex computation, you have, joining of 10 or 15 tables together that you don't really want to expose to the application developer, you can define a view on that and then just hand them the view and tell them, hey, you have this view, feel free to use that in the application. You don't need to know the details of how we're computing this data. So this makes the application developer's life easier, because they can focus now on what they want to do with that view rather than getting bogged with the details of how this view is computed. Another advantage is what we've talked about in the beginning. If we want to reuse that computation multiple times or in multiple places, then we don't have to write it all over or copy it multiple times. We just reference that view everywhere. If we want to make changes to the view definition, if let's say we want to change how the computation is done, we only have to change it once in the view definition. So we just change it there, and everything that uses that view will automatically start using the new computation, whatever it is. So only one source to update. We don't have to worry about trying to find all the locations where it's being used, or worrying about possibly making a mistake or missing one of those. So only one place to update. That same concept of hiding the details can also be a disadvantage in some cases, right? Especially if you have a bug or like you're trying to find out a problem with the query. As an application developer, when we're using CTEs, right? CTEs are visible. They're part of the query. They're defined in the beginning and you can see what they're doing. But the view definition is now hidden. You don't see what's happening there. So if you're debugging your query, you usually assume that the view definition is correct. And if it is not correct, it might be a little difficult to try to trace it to where it's defined and figuring out what it's actually doing. So you have to do some extra effort to get that definition and see what's happening there. It's not obvious from looking at the query that just looks at the view as a virtual table. So it introduces a little bit more effort when you're trying to debug things. Another important aspect where views are very helpful is access control. Access control is very important in databases in general. Usually you have ways of restricting what people can see or what they can read or write and so on. This is a huge topic. We're not going to cover all of it today. I'm just going to talk about a specific part of it that concerns views. The idea is that you can use views to hide certain fields or hide certain columns from certain users, or even you can hide the view definition entirely as well. Let's look at an example. Say we have the customers table, right? So if we select start from customers table, here's what we get. We get the customer ID, the customer name, and the address. Let's say we define a view that looks like this, that selects the customer ID and name, as well as the sum of the amounts from all the customers' orders. So this view will look like this. If we select star from this view, this is the data that we get. Now, suppose that the customer address is somewhat of a confidential information, and you don't want to expose that to everyone. So you can easily restrict the access to the customers table. You say that not everyone, maybe only the administrator will have access to that customer table, or a particular database user that has high privileges. But for everyone else, you give them access to that view that we just created. So this view only shows them the customer ID, name, and the amounts. It does not show them the address. And if they try to query the original table, they will not have access to the address column. So this is one way of restricting access to some confidential data, or just allowing certain users to see certain things. You can also restrict access to the view definition itself. So like if someone tries to see, okay, like how is this view results defined, you can also restrict the access and give certain people access to the view definition. Certain people would not be able to understand how this is happening. This is very useful when you have, like, let's say a computation or a formula where you don't want to expose the details of that computation, but just give people the ability to see the results of the computation. So this is one way you can use views to manage that access and figure out who can see what in the data. Again, like I said, this is a big topic. I'm not going to get into the details of that, but yeah, I can happily make another video on access control and permissions and stuff like that if that's something that's interesting. One thing that I have to mention about views as well is the use of views to update data. All the examples that we've seen so far were using views as a read-only virtual table, right? So you reference a view and you just run the query and read the data corresponding to that view. This is the most common way of using views for reading the data. There are some scenarios, or there are some use cases where people want to use views to update the data, but these are not super common. So most people, when they talk about views, they think of them just as read-only objects. But it's worth mentioning also the update part. To use a view to update the data, remember we said that the data is not physically stored on disk. Like the results of the view are not physically stored on disk. We have the base tables, and every time we want to read the view, we execute the view definition. So how do we update the view if its results are not stored on disk? Updating a view means updating the base table that the view is reading from. For that to happen, some conditions have to be met. So it's not always possible to use views for updating data. First of all, an updatable view can only be defined on a single table. You cannot have the view definition referencing multiple tables. We have seen in the previous examples a view definition that has a join, for example. If your view definition has a join, you cannot use that for update. It will be read-only. Another condition is that each row in the view has to map to a single row in the table. What does that mean? Let's say, for example, your view has a group by. You're saying group by customer ID or something like that. This means that each row in the view is coming from multiple rows in the table that are being grouped together into one row. So in that case, you cannot use this view for update. Same thing if you have something like select distinct. So each couple of rows in the table, you select a distinct value and it ends up in a single row in the view. Again, in that case, you cannot use this view for update. So each row in the view must be coming from a single row in the table. Any operation, so besides group by and distinct, any operation that violates that will make this view not updatable. Another thing is that any update operation that you do, whether it's update or insert or delete on the view, you cannot violate any constraints that you have defined on the table. For example, let's say a certain column cannot be null in the table, and you try to do an update on the view that makes this column null, or like you're trying to update the value from something to a null, and that violates the constraint in the table. In that case, this operation will not proceed. So there is a bunch of conditions there that have to be met in order for being able to use a view to update the data. But again, this is not a very common operation. I'll show you a small example just to get a sense of what is happening. So suppose that we have the orders table. Let's just describe it to see what it looks like. So we have all these columns and we have some indexes and so on. Let's select star from the orders table. So we have all these orders. Again, we've seen those before. Each order has a customer ID, amount, and so on. Let me create a view, let's call it expensive orders, which only has the order number and amount from orders that have an amount greater than $100. So we see that we have 3 orders here that satisfy this condition. So if we create this view, and then if we select all the contents of this view, as expected, we're going to get these 3 orders, and we can see their amounts here. Again, this query is reading from the base table and applying the view definition, right? All right, so now let's try to do something like this. Update the view, set amount equal 300, where order number equal 104. So for that order, we want to update the amount from $200 to $300. Here, the update was successful. So if we look at the view results again, we can see that the row with order number 104 has been updated. This also is reflected in the original table. So this view is built on the orders table. So if we go and select star from orders, we can see that the row has been updated there as well. So if you look at the row that has order number 104, now it has an amount of 300 as we have seen. So again, there are certain conditions for this to happen, but yeah, this is not a common operation, but it's also good to know that it can be used. Cool. All right. So this is what I wanted to talk about today. To summarize, today we talked about views. Views are named queries that are defined and stored in the database. Only the view definition is stored, not the view results. As a side note, there is a special kind of views that's called materialized views. For materialized views, we actually store the results of the views, but we did not talk about these today. We can have a separate video about that. But the views that we've seen today, we only store the definition, but not the results of the view. Each time we use or reference the view, the system will go and run that definition query and then return the results and maybe apply certain other more operations on top of that if this view is used in a query. Views are used to simplify queries by hiding some of the details. It's also used for reusing certain subqueries between several queries in the application. If you need to update the view definition, you can do that, and this will be reflected for everything that uses that view. It can also be used for access control, for specifying who can see what. So you can give access to certain users to the view, but not to the base table. This way they can see certain parts of the data, but not other parts. We have also mentioned that views can be used to update the data in certain cases. if the view references only a single table, and if each row in the view maps to a single row in the base table. So this is all I wanted to talk about today. I hope this has been useful. Please let me know if there are any questions or if anything was not clear. Put them in the comments and I'll try to get to that as soon as I can. Otherwise, if you like the video, please hit the like button, subscribe to the channel if you have not already. And with that, thank you so much for watching, and I will see you in the next video.